Hello everyone. Today I'm going to demonstrate my final project of the course ADTA 5560, which is a recurrent neural network. So this project will consist of the total 6 parts. First part is about how selecting data set of time series data set, and second part is about creating the sine wave data using the simple RNN model, and the third part is about understanding what are the challenges we face in the vanish gradient and exploding gradient in the RNN, and how we can overcome with the LSTM model, and what are the advantages about LSTM model to overcome those issues which we face in the simple RNN. And the fourth part is about creating the LSTM model for predicting the stock price of the company. And fifth part is about creating the LSTM model for improving the performance. So here for the stock price prediction, I'm using the Google stock price prediction. Um, and the sixth part is about comparing those two network performance of the models. And the seventh part is about understanding till now what we have understood about a simple RNN, and what is LSTM model, what is the advantage about that. So let's dive into the first part of our selection of time series dataset. Here, for selection of the time series dataset, I have selected the air quality. The source I have selected from the archive machine learning from the source from this website. And data consists of total data points of 9,358. And it has a simplified metal oxides sensors indicating the air quality chemicals. And this device is placed in the highly populated area where the road transportation is more. Especially, it is this data is collected in from the city of Italian city. So the collection of data is from the March 2004 to Feb 2005. It is a 1 year data set. So let's dive into the data dictionary. What are the variables, and what is the description, and what are the data types of that? So here we have the date field for recording of the time frame to know the time frame of the data set. It is a data type as date, and the time, which is in the time format, and it is a categorical data. And we have a CO of GT, which is a truly hourly average concentration of CO in mg. It is for referencing the analyzer. It is in data type is integer. So in this way, we have all this data with the variable names and the description and the data types. So let's explore about our next topic is how to create the simple sine wave using the simple RNN modeling. So before creating working on the creating the model using the RNN, let's understand what is RNN is. RNN is a simple perceptron form of neural network, which is consist of the single neuron, uh, where each of the symmetries which we see here as the circle one has the weight of the previous state. So here what we get, like each input, whatever we pass from this input signal we get from input can be a form any like text or the speech or the video form, any kind of input which is supplied to the simple RNN is multiplied with the weight, uh, and then it is forwarded to the feed forward layer, and then decide whether it has to be or forwarded to the output or not. So here it is a simplified processing of sequence of data. Let's say that the data can be like from x1 to x7 with the time indexing ranging from 1 to n. So And the advantage of using the RNN is that it has in-state memory, which capture the computer information calculated during that processing stage. And the feed-forward formula used in this, like observing the total loss for a given input sequence paired with the output sequence of value y. So whatever the sum of that will give the sequence is the forward pass formula. So for that we use the softmax function to obtain the output vector y for probabilities of the output. So this is the simple RNN network diagram for my uh, my dataset selections. Like I have selected the total data points of 2048, and for one simple RNN, I have taken the total neuron of 80 and have selected the one dense layer, and this is the output. So each simple RNN will have the feedback loops for storing its state. So that's why it is called in-state memory. So let's dive into the code. So this is my Python code, which I have created in the with the help of a Google Cloud Console, by creating the compute engine and run the local host of the Jupyter. Then I have run this code in that. So let's for creating the simple sine wave, first we need to import the Python important libraries such as pandas, numpy, matplotlib, and this for related to make the TensorFlow performance, we need the Keras model, sequential model, and the simple and dense. This is for layering because we are having the two-layer architecture in the diagram. One is simple RNN and another is a dense one. Dense is nothing but the feed forward layer. So, and then we are creating the time series generator and the min max scalar for normalizing the data in the range of 0 to 1. And we for generating the sine wave, I have created here the used line space for the data range of 0 to 72, and this is the total data points which I want for the project to generate. And I have printed the x and y values, and I have plotted the x and y. This is a sine wave which I have plotted from the previously generated data. And I have loaded the data using the data frame, using the pandas data frame into the framework DF. Then I have printed the first five data sets. And here we can see the total length of the data set is 2048, which is the data points which we required for this project. And then let's go to the train and splitting of the data. I have selected the split percentage for the testing as 20%. 20% of the whole data is has splitted for the testing purpose. And the length of that is 4,000. I have rounded that to the nearest value, which is 410. And then I've calculated after splitting after knowing the length of the testing data, we need to understand from which data point we need to import that data for the separate test data frame. So for that, I have calculated the test start index, which is 1,638. From that value to the 2048 is the data selected for the testing purpose. So have created the separate data set for training and testing purpose, and we have printed the same for that. And after splitting the data into the train and test, we have normalized using the min max scalar, and we have fitted the data set and transform the data using the scalar dot transform function for the test and training data set. Then have selected the input sequence as a input sequence length of 50. For each 50 input, it will predict the 55th value of the data. So for that, I have selected the 50. And this is a then we have to create a time series generator for that. In the parameters, I added the normalized train, normalized tray length, and batch size as one. This because this is the first batch I want to generate the sequence of the output predicting. Then I have built the simple RNN model. For this, I have created one features because we have only one values, which is a sine wave in the data set. And I have created a sequential, defined the function using the sequential, and I had a simple RNN using the add function and simple RNN in that. And here we can see that it is the number of neurons I have added for the simple RNN to perform the function. And here is a dense function, which is a feed for a fully connected forward layer. For that, I have added only one. So after compiling the model using the mean square error, we can compute the what is the percentage of performance of the model. So in this output, we can see that simple RNN has a total 80 shape, 80 neurons, and the dense layer has one. And once done with the compiling and now we have to train and fit the model. After training and fitting the model, we can see that this is a uh, loss plot from the data which you have predicted. Loss plot is defines like how what is the difference between the actual and the error in the values. So here we can see that there is a steep decrease in the and there is again increase and there is a decrease and there is final flat approximately like zero in the 3.0 to 4.0. We can say that this model can be more improvised because there is a small increase and a decrease in the model. And after that evaluation, we can see that this is a length first evaluation of the model. This is the output we got from the first evaluation. And then reevaluate the model for the remaining data set and apply the same. And now after evaluation, everything is done. Inverse transport the normalization which were applied in the previous state to get the final data values. After this is the actual data set which we see here, we have only one feature which is sine. But after the predictor values, we can create one another feature by name predictions here, and then we can add that prediction values in the data test. So here, if you see, we have the sine data set, which is of actual values, and this is the prediction, which is predictive values. So let's plot the diagram using those values. So here is a graph which I got using the actuals and the predictive values. So if you see here, this yellow line is about the prediction and blue line is about the sine wave. As a sine actual values goes, the prediction lines are going over and under at some points. So we can say that this model might be overfitted, or at some of the point like here, 62, it's underfitted. So we can improve the model performance by changing the neuron levels of the simple RNN or else improving the prediction batch of that model. So this is the simple RNN sine which I created using the simple RNN. So let's explore the second, what is the next option, next part in our project, which is understanding about what is a vanishing gradient problem and what is a exploding gradient problem. So let's understand what is vanished gradient problem. So when we are increasing the number of layers in the neural network architecture, this activation which is represent like the sigma type, it will implement a loss function to zero, making the network to train a bit harder. So reason for that is like when we activation function squeeze the large input space into small input space in the range of 0 to 1, which cause largest changes in the input of activation function, causing the small changes in the output. Therefore, deviation, what we are seeing, the deviation here, like in the red dotted lines, it's become small. So this is the reason why gradient vanish is a problem in the simple RNN. And the solution for is by implementing by using the functions, activation functions like ReLU, which does not deviate the as a layer, which does not deviate the layer as it progress. Like if you keep on increases a layer, it does not deviate that. And another solution for this is batch normalization. We can normalize the batches so that a large input space is mapped to the small one, causing the deviation to disappear. So it will reduce the problem by normalizing the input. So the determinant of the input does not exceed the outer edge of the sigmoid function. And this is a simple function about that. So let's exploding gradient problem in the simple in the neural network. As the direction and magnitude of the error gradient are determined during the neural network training process and are utilized to update the network weight in the appropriate direction and to the appropriate degree. This error will build up during the update in the deep network or recurrent neural network, which leads to the extremely large gradient. This large gradient of the network weight as a result to lead to an unstable network. So, so we can see that there is an NAN values will occurs on the weight every extreme points wherever they overflow. Okay, so for that, gradient values sometimes become like greater than one uh, and they are multiplied with the network layer, causing the explosion throughout the exponential growth. So, and solution for this issue is I have mentioned here the three solutions for that. One is redesigning the model of the network. Uh, while this can be implemented while training the network, there might be some advantage of using a small batch size. As we have seen in the previous coding for the sine wave, I have used the batch size of 32, sorry, 60. So if you use the batch size as smaller as that, then this explosion will reduce. And also by employing the network with a long short-term memory. Yeah, this is the next topic we are going to code on that to show this how LSTM will remove this gradient explosion problem. So this LSTM will have unit has a memory unit and possibly related to gator type neuron structure. So it mitigate the explosion gradient. And make use of gradient clipping is another solution for this model. Even with the deeper multiplayer perceptron network and larger batch size, as well as LSTM with the very long input sequence length, explosive gradient can still happen. So for that, if explosion still happening, we can look in and set the gradient size limit when you're training the data. So this type of setting of the gradient size to particular limit is called gradient clipping because we are limiting the gradient size with that. So let's understand about the simple limitations of the simple RNN neural networks. And some of the drawbacks of using the simple RNN are overfitting and vanishing gradient, local minima, this which I have seen in the previous one. So overfitting is like when network overfits data, it fails to generalize new data and instead memorize the training data set only. So inaccurate forecasting will happen because of that. So to regulate that strategy, we need to drop out weight decays and early stopping can be minimized that overfitting issue. Vanishing gradients, for that I have already said in the previous one, by implementing the activation function with the like ReLU, we can minimize the vanishing gradient issue. And local minima is to find a suboptimal solution that is not the best option that may become the stuck in the local minima. This may hinder the network ability to perform better and realize its full potential. So these two strategies are for avoiding the local minima is uh, stochastic gradient descendant, which adds noise and random to escape from the local minima, and momentum, which quickness the gradient descent. Let's understand what are the advantages of using the LSTM model, which is a long short-term memory network. It is a unique class of RNN that has ability to learn long-term dependencies. It is introduced by the Orchiter scheme in 1997. Numerous individuals improved and popularized them. This has become more popular because it has is incredibly well on wide range of problems. Uh, Yeah. So this is a overall architecture of the LSTM. So every recurrent neural network is composed of series of neural network model that repeats. The repeating model is convenient to RNN will have very basic structure like a single tan layer. The horizontal lines which passes through, like here see, is a line pass through the type of the represent the cell state. In certain vessels, it resembles the conveyor belt. Uh, with the help of this, in this LSTM architecture, we can see that there are total three gates, which is a forget state, input state, and the output state. Let's understand more about that in further analysis. So in this, we can see that there is a point one multiplication operation sigmoid neural net layer number, which is ranging from 0 to 1, produced by the sigmoid layer, which indicates that how much of each component should pass through, where 0 indicates like it has passed nothing, where 1 indicates it has passed some amount in that. So these three gates of LSTM will safeguard and regulate the cell state, determining the which data has to be kept and which data has to be discarded. So the first gate of that LSTM is forget gate layer, which is a sigmoid layer, which is seen in the here. So if it keep the value as 1, then it will represent that the completely keep this, like input keep the values totally, and if there is 0, then it will say that get rid of this. And the next one is input gate. After the tan layer uh, generates the vector c minus t of potential new candidate values that could be included in the state. We'll combine these to produce a state update in the following steps. The old state like ct minus 1, which is the previous state, needs to be updated into the new cell state ct, and everything already has been decided in the preceding steps. All that remains is to carry out, and we need to multiply the state with the ft, this one, disregarding the information we have previously chosen to ignore. Next, we should include the C minus T. This represent the updated status candidate value adjusted for the amount that we have chosen update each state value. So this is and the output state is about whether the data has to be kept in the state or has to be moved into the next state. So next, explore the time series data using the LSTM model. So in this model, I have built, let me explore the first fourth part. In this, I have imported the same imported libraries, pandas, numpy, and matplotlib. And here I have imported special layer like LSTM and dropout layer. These two are the another two layers of the grading model. And I have imported the here data using the I have imported the Google stock price data. I had selected the data from the time frame of Jan 2015 to um, June 2020. So here we can see the total shape of this data is 1382, and it has totally 7 attributes. And this is a normal presentation of this actual closing price of that stock prices, and have set this input length as total 60, and I have split the data on 10% as a testing data, and then I have split the index, splitting index of the testing data is 1244, and we have printed the test and train data sets. Next, we have applied the normalization function on the uh, train and test data set, and we generated the time series for the training. This is we have set the batch size to 32, and created the time series generator for that. Then I have built the model, defined the model using the sequential. LSTM has the 15 neurons activation function, as I said, ReLU, for helping in the vanishing gradient index to overcome that issue, and dropout percentage as 20%. And we have used total 3 layers of LSTM and 2 layers of dropout and one dense layer. So in the using the loss mean square error method, you can see here the summary of that model. And then have trained and tested using the 100 epochs. And let's see the loss percentage. Here we can see the model performance is much better because we have consistent consistent zero over the overall this 100 epochs values. And then we have set the batch first for evaluation the model. And this is the first evaluation prediction models output, which we see that here is a slight increase and decrease in the stock prices. And then next evaluated the next batch of periods for the 106 forecast. We have forecasted the model for the 106 data points. This is the forecasted output. As you see, there is a inversely decrease in forecasted stock price of the Google. And here we can see that how is the actual and the forecasted values are presented in the graph. So as we see, there is an incremental increase in the actuals, and there is a decrease, steep decrease in the forecasted value. So here, when we see the separate of the forecasted value for the size of 106 data set, this is actual values, and this is the forecasted values, which is much difference in the value. So we can't say that this model is predicted um, as we as I said. So let's redesign the model for the to let's say to whether the model will improve or not. So for that, I have redesigned the model, imported all libraries, imported libraries, which I did in the last code. And here I have made the changes as input sequence as a 61, and I have split the data, split testing data to the 20%. And I have said changed the batch size to 40, and I have set the LSTM size to 60. Each neuron will have, so LSTM has, so LSTM, each layer has 60 neurons. And as I see here, we have got the same loss plot which you have found in the previous model. And here is the prediction model for the with the actual and prediction plot stock price. Here is a steep decline in that. So when compared to both models, I didn't find much difference in both model because in the end both predicted it the same way. Like we see in the previous one, it is the same as in declined and forecast and actual ones are totally far apart in both the models. So that was about the comparison between the both models, which I already mentioned using the code. Now I understand the simple RNN and LSTM model. So as we already said that simple RNN has few of the disadvantages like gradient and overfitting. So all those can be overcome with using the LSTM model, which has instead and back propagation feedback loop in that. Using because of that we can degrade that issues which we are facing, which we get encounter using the simple RN model. So I have mentioned the references from where I have taken the data set using from the UCI machine learning repository. Yeah, thank you for hearing me.